Okay, so fractions are a thing that exists, and sometimes we have to take the derivative of one, and so there's a derivative quotient rule. Like with the product rule, there are a lot of different ways to write this. You might see gf prime minus fg prime over g squared. There's another version that's u prime v minus uv prime over v squared. And the version in my head is bottom d top minus top d bottom over bottom squared. So you're about to hear that a lot in these lessons. That's my memory trick. Let's see how it works. We'll tuck that away in a corner. Shrink it down so you can look at it if you want to. Okay, so the derivative of this, df dx, is the bottom, 5x minus 1, times the derivative of the top, which should be 39x squared. So bottom d top minus top, 13x cubed. Derivative of the bottom, well, the derivative of the bottom is simply 5. Here you get 1 times 5x to the 0. And the negative 1 is a constant, so its derivative is 0. It just vanishes when it's differentiated. So bottom d top minus top d bottom all over the bottom squared. 5x minus 1 all squared. We could write that twice and FOIL it out. I generally don't, because it generally doesn't help. It doesn't make the expression any better, and for some things that we're going to do later, it's more helpful to have this in factored form than to have a great big polynomial. So I claim that we can get away with just leaving this alone. df dx. We can, however, clean up that numerator, and we're going to. 5 times 39x squared is 195x cubed, minus 1 times 39x squared is that, and minus 13 times 5 is 65x cubed, all over 5x minus 1 all squared. Okay, for x cubed, 195 minus 65 is 130x cubed minus 39x squared. No changes in the denominator. And yeah, I think that's about as good as it gets.